You're probably all wondering why I'm here. You probably think I'm here for you to beat me up about coverage. And I will address that, and I'll give you your chance to do that at the end. But as Phil said, really, I'm in a different role now. What I do is I look at beyond Telstra's current business, what is our future going to be? And that involves me looking at new technologies, understanding what the implications are, and then conducting thought experiments. So a thought experiment is where I look at technology and say, if we had this technology, how would we use it and how would it change what we do? And the technologies that I'm examining at the moment affect every aspect of the Australian economy, one of which, of course, is agriculture and a very important aspect. So over the last year, I've had a look at various changes that might occur in agriculture, and that's caused me to speculate about the sorts of farms that your children will be farming in the future. So in 2050, it's quite feasible. Now, I'm not saying this will happen. I'm just saying these are the directions that we seem to be heading in. It's quite feasible farms won't have people on them because everything will be automated. There'll just be robots buzzing around. It's equally feasible that they won't have animals on them because we're seeing synthetic proteins come about where meat, milk, leather will be manufactured in factories without an intervening cow or sheep in the middle of it. We're seeing technologies that will allow us to increase the unit of production on the land sixfold, our water usage efficiency 20-fold, production that is weather impervious, so you don't need to worry about that anymore, and the ability to take your product all the way to market, branded and tracked and validated as yours coming off a particular farm. So that's kind of where the world's going, and what I want to show you is how we might get there. By the way, this just some statistics that Cisco, the big telecommunications manufacturer, put up a couple of years ago on these new technologies, on the sort of impact they have on the economy. Notice things like healthcare at $3 per doctor's call. I think we'd all like to see us get there. Education, $3 per student per month. We're already seeing companies deliver education in Africa commercially for $6 per student per month. So these things are not infeasible. They're just not here yet. Okay, so what I'm going to do is I'm going to briefly cover today where we are to date in terms of what we've seen from a digital transformation perspective. Then I'm going to give you a sort of a bird's eye view of the emerging technologies, and then I'll give you some indications on the way people are applying those technologies to digitize the farm. So in today's world, over the last 40 to 50 years, in fact, in my working career, we've seen three major developments transform the world. We've seen the internet. That arose about 20 years ago in reality from a wider economy perspective. We've seen fixed and mobile broadband, which is what you guys are going to beat me up about, but those have been going sort of 20 to 10 years. And then over the last 10 years, we've seen our computing move from our desktops or local data centers into the cloud, so to speak, where you get your computing from some provider whom you have no idea where their data centers are or whether they're even based in your state or in your country. And that has led to quite a significant change in the economy to date. So we've seen things like the on-demand economy. The millennials don't watch TV broadcasts, they watch it all on demand and broadband. We've seen the sharing economy where people are starting to do things like Uber and GoGet, where you don't own your own car, you just share someone else's, or Airbnb. And we've seen the crowdsourced economy where the media is being replaced by citizen journalists, if you like, which has, of course, now created the problem of fake news, which we're going to have to address through some of the technologies I'll talk about. So that's today's world. Let's have a look at the technologies that are starting to emerge. And the first thing we're seeing is what we call in the industry the Internet of Things. So today's Internet is about us people connecting to computers. The future Internet is about things connecting to computers. And things are things that you measure. So the mobile phone, because we produce billions of these a year, has led to 4 sets of sensors that are cheap and are connected. Cameras, microphones, location, and movement. And those sensors are dirt cheap, and they're connected, and you can have them online. And that's got people thinking about, what else can I measure? So I can measure things like the pollution in the air. I can measure the performance of human bodies. I can measure all sorts of things. And because I've got all that microchip technology there, I can actually connect it as well. So that's the first thing. If we're going to make that, we obviously need all those sensors, which is the part I've just mentioned. We need networks, which I'll get to next. And you also need this cloud computing capability, which has got all the data centers and the software, more importantly, that enables you to collect and manipulate that data. And then on top of that, people will start creating applications. So you may have an application for water management. It will still use all the same infrastructure, or you may have an application for harvest readiness, and I'll tell you about a few of those. And things like controlling your tractor, those are all built on top of what I've called here a horizontal platform. In other words, something which is like the internet, which is shared across all aspects of the economy. So let's talk about those networks, because obviously that's of key concern. And you're going to say to me, well, that's all well and good what you're talking about, but if I can't connect, I can't do anything with it. So the first thing you need is coverage. We understand that. That, by the way, is coverage map of Telstra's network. Just to point it out, it is twice as big as anyone else's in the country. It's 2.5 million square kilometers, roughly, about a third of the overall land area of Australia, and it covers about 99.3% of the population. That network, by the way, is 5.5 times the entire land mass of Germany. And for those of you who've been to Germany, you'll know that their coverage is not universal. But in this new world, where we're going to collect literally billions of devices, we need to make sure that the network's got capacity. Most importantly, a lot of these devices are going to be battery powered. The network can't flatten the battery, so you've got to worry about that. Some of the devices are going to be moving at high speed, and some of them are going to require very reliable communications and very quick communications, or what we call low latency, like if you're doing remote operations, which becomes feasible. And you have to ensure that some kid downloading a movie is not flattening the network when you're doing an operation remotely, so you have to have, again, what we call quality of service. In terms of achieving that, there are three ways in which the world's moving. The first is that we're evolving the cellular networks, the mobile networks, to meet those requirements that I've just outlined. And ultimately, that will win because of the scale. When you've got billions happening, then you win because of scale. But in the meantime, there are people building networks, other solutions, which are more specialized. So you may have noticed that South Australia, for example, has just deployed a technology called Sigfox, which is designed specifically for the Internet of Things. They've deployed it across the state in order to connect up all these things. Now, let me deal with this issue of coverage, because, as I said, it's not much good if you haven't got it. And you also recognize that you can't cover the whole of the country with a cellular mobile network. It's just not economically feasible. But what's happening is, fortunately for us, there are 3 billion people in the world today who do not have coverage. Why is it fortunate for us? Because no one's going to build new technologies for a few 100,000 Australian homes that don't have coverage. But if there are 3 billion people out there who can be connected, still to be connected to the internet, then there's a huge amount of economic incentive to do that, and to do it cheaply with universal coverage. So we're starting to see 3 sets of technologies emerge that are going to make this possible. And the first and most important is what are called low Earth orbit satellite systems, or LEO constellations, as they're known in the trade. These are satellites that, instead of operating at 30,000 kilometers like the NBN satellites do, which are known as geostationary, because they sit in the same position in the sky the whole time, these satellites are operating at 500 to 1,000 kilometers, and because of that, they're moving across the sky. So you've got to have an antenna that is pointing and following the satellite and then going, whoop, next satellite, and keeps doing that. Now, until recently, those types of technologies were very difficult because you had to have mechanical antennas that were moving across and had to be carefully set up and calibrated and pointed. And that was an expensive business. today we're seeing new antenna systems, which are flat antenna systems. They use electronic steering. The way they'll work is someone will post you a thing that looks like about the size of a laptop, and you'll get an instruction which says, find some open sky, put the thing down there, put your mobile phone on top of it, and we'll run an app which will set the whole thing up for you. So that becomes cheap and easy to do. The other thing about the satellites themselves is because there's so many new satellites doing things like weather and agricultural things, as I'll talk about in a moment, these satellites are becoming cheaper and lighter and therefore cheaper to launch. So we're seeing at least two major global consortia who are building these LEO constellations for launch within the next 3 years. And the important thing about those LEO constellations, they're in polar orbits, so they're pole-to-pole coverage, 100% coverage on the entire globe. And they offer service which will look exactly like the service that I get in Melbourne today on a cable network. Roughly the same speeds, roughly the same delays, and it'll be absolutely transformational in terms of the way in which you use the internet. There are other people who are trying other solutions. So Google have got this project called Loon, which I usually call Project Loony because it's so far-fetched, but where they're using balloons and they send these up into the stratosphere and they just float around the world and they act like high altitude base stations. Not dissimilar in the technology to these satellite constellations, but a completely different proposition from how they built. And again, that's untested and will take some time. And then Facebook are you working on a drone which you'll put up in the stratosphere and it'll act like a base station in the sky and therefore give you much wider area coverage. So my guess is you'll beat me up today because you haven't got what you need in terms of coverage and capacity. I know that. But in 5 years' time, when I come back, that'll be yesterday's conversation. It'll be boring because that'll be solved by one of these types of solutions. So you've got to think in terms of, yes, you've got these problems today, but tomorrow you won't have them. Okay, let me now get on to how this is all going to come together, because the important thing is data. You're collecting all this data from your environment, all over your environment, your body, your farm, your soil, satellites, the whole lot. And you've got to put that data into a computer system that is able to analyze it. And we're in a new world in that respect because these computer systems, which I've called here a data lake, these big data systems, are able to throw data at the problem in a way which we've never been able to do before. And that creates what we call machine learning. So I won't try and explain machine learning in detail to you, but it's a fundamental change in the way we do computation, because machine learning is exactly like how we as human beings learned. When we were a baby, our parents said to us, don't put your finger on the stove, it's hot and you'll get burnt. And of course, we put our finger on the stove and got burnt. And we learned, don't put your finger on the stove, because we got some data about it. The same thing's going to apply in this new world with machines, where you just throw the data at the machine. You have no idea how it comes up with an answer, but it does come up with an answer. And the remarkable thing is it works. So I'll give you an example here, and this is the only graph I'm going to show you, I promise, which is how machine speech recognition. So if you look on it, we've been working on speech recognition, the ability to be able to talk to a machine from the 1970s. And at this level, it's completely unusable. So it was buzzing along for 40 years with absolutely no improvement at all. These improvements are of no significance. In 2010, Google came along. They had a whole heap of data. They threw that data at what's called an artificial neural network, and hey presto, out of it pops speech recognition that actually works. Last year, IBM or Microsoft, I forget which, announced that they developed a speech recognition system that was better than a human being at recognizing speech, because it could do things like reject noisy environments. So we're literally now at the point where you can talk to your house. And in fact, I'm not crazy, but I do talk to my house on most days, because I'll ask it to play music or to turn the lights down or to do things like that. And of course, you're talking to your car, and you'll be talking to your tractor, and you'll be talking to just about anything where it makes sense to talk to it as an interface, because it works better than trying to do it on textual interfaces. And we're going to go beyond that. So people are already working on this, where you can actually start using your brain waves to control things. Now, at the moment, that's focused on people with disabilities, obviously. So, for example, they've been able to use brain waves to get people to type. People with Lou Gehrig's disease who are paralyzed, they can use their brain waves to actually do typing. And it's, it's not 80 words a minute. It's about 8 words a minute is the state of the art. But they actually are able to take the thoughts directly out of this person's brain and enable them to type. They're enabled to take thoughts directly out of people's brains and enable them to reuse limbs that have been paralyzed because they are paraplegics or quadriplegics. So that is kind of the next step in the journey. Then another important aspect is our visual system, and people have come up with a technology called virtual reality. For those of you who are familiar with it, Sony have a set of glasses you can put on a PlayStation which enables you to play games in 3D. And Facebook have bought a company called Oculus that does it. But essentially what you do is you put on a 3D glasses, and those glasses track your movement around as you move around. So it's like working in a 3D world. You actually are immersed in that world. Now, at the moment, it's highly focused on games, and also at the moment, it makes a lot of people feel sick, which is kind of a disadvantage. But there are ways around that. So with time, what will happen is you'll be able to put these 3D glasses on and immerse yourself into a different world. And this is going to have huge implications for education. So obviously, one of the tyrannies of distance is education, and that will be overcome by technologies such as these, because you won't actually have to physically be in the classroom. You'll be able to transport yourself or teleport yourself into the classroom, and more importantly, into the laboratory. You'll be able to work as though you're actually in that environment. And then there's another variant of that, which is called augmented reality, and this is much more important in a way, because what augmented reality does is you wear a pair of glasses. They're not fully immersive like virtual reality. You can actually see the real world around you. But what the glasses do is they take that real world, they digitize it, and then they meld into the real world, the digital world. So you create a mixed reality, which is a combination of the real world and the digital. And for many tasks, such as maintenance, this is going to be extremely important. So in this particular example, which comes from Microsoft, this girl is trying to do some plumbing in a flat, and her father is helping her out by sitting on his iPad. He can see exactly what she's seeing. He draws on the screen, and when he's saying to her, change the U-bend, the blue line, squiggly line, appears to her as though it's actually on the U-bend. It's not overlaid there, it's actually sitting on the U-bend. This is a real example where BMW have been experimenting with this technology for their mechanics to do maintenance. It actually overlays the information about the engine onto the physical engine itself, so they can give the mechanic instructions, put the torque wrench on here, apply 3 Newton meters, pull it to there, etc. Which means that you can get non-specialized people to do specialized tasks by just giving them these instructions. Obviously, every organization that's in a service business is really interested in this type of technology. Okay, so those are the kind of technologies that are emerging. There are a couple of other things. There are a couple of gotchas, as the American says. The first is, if we're going to do human-like computing, which is what we're talking about, we've got to be able to compute like a human being. And it turns out that human beings are quite remarkable. Someone worked out how the computing power of a human brain, which is, if I'd given you this presentation last year, that's the figure I would have given you. But in fact, someone's recent research has showed that it's something like 400 times more than that. So our human brain is this unspeakable number, which is about 4 exaflops. That's the current state of the thinking. The world's largest supercomputer is about 1/400th of that, which is a Chinese computer. But the amazing difference between the two is our brain uses about 20 watts of power, the equivalent of a LED light bulb, and this thing requires its own power station. So the fact is that if that's the way computing goes, we're not going to be able to do the number crunching we need to create this new world. So people are working on new ways of doing computing, and as Phil mentioned, I was on a conference call right now about this type of computing, which is called quantum computing, which will potentially allow us to solve problems that we've never been able to solve before, particularly things like optimization problems, and more importantly, these artificial intelligence problems. So Australia is actually a leader in that field, and it's something that we're putting a lot of effort into because it's potentially one of the ways in which we're going to create this new world. The other thing we have to worry about is cybersecurity, and if you're not worried about it now, you should be. So there are a few things you need to do in order to protect yourself, keep your software up to date for sure, and also use two-factor authentication for everything. I'm happy to explain that in detail if you want at the question time. But what's going to happen in the new world of the Internet of Things is we've got a whole lot of new attacks coming on because these devices are all over the place and they're not nearly as intelligent as today's computer, and therefore in some ways they're much easier to attack. So there's a thing, for example, called a denial of sleep attack, which until recently I thought was my wife's tactic when we were having an argument at night. She just carried on until I gave in through sheer exhaustion. But you can do, it turns out you can do exactly the same thing to a battery-powered device. You can just send it information and it'll run out of battery, and that then kills its functionality. They're obviously also in the physical world, so you can go out and tamper with them. And that means you've got to put in place a whole lot of security tactics to prevent that, and that is something where the industry is a bit immature today. And you'll see, I put this picture of the drug pump up there because, in fact, a drug pump recently got hacked. They had to withdraw 1.1 million of these things from the market because someone on the internet could hack the drug pump, change the dose, and leave the display the same. So you literally could commit murder by internet with that sort of situation. So that's obviously unacceptable. It's not in a mature state now and will mature over time. Okay, so let me get to the third part, which is what does it mean for farming? And some of this stuff you'll say I'm dreaming, and some of it may seem confronting, but these are all things that are happening in their early stages today. So the first thing is we're seeing increasing use of drones as a platform for mounting sensors. And you can not only use them to measure your land, but also to do things on the land like precision spraying or precision fertilizer application. Another way in which people are doing that same measurement is with satellites. So there are companies in the States, there's a company called Descartes Lab, for example, who are doing the crop prediction for the US grain industry. Apparently there's a whole financial market around this and that gives them an opportunity to arbitrage it, because the way the yield prediction works today is that the US Department of Agriculture sends people out to individual farms to ask the farmers how their crops are going, and then they do an estimate, an aggregate estimate on a monthly basis. These guys, Descartes Labs, take all the satellite data across the entire US. They apply what's called hyperspectral imaging, which allows you to do things like see chlorophyll production as a proxy for the rate of growth of the plant. They then put that into one of those artificial intelligence algorithms that I mentioned, and every 2 to 3 days, they can do a prediction that's 2 to 5% more accurate than the USDA's prediction, and therefore get much more up-to-date and real-time prediction of crop yields. Then on top of that, there are companies like a company called Gamaya, who I met in Switzerland recently, who are taking that data and telling farmers on an individual basis by 10 square meter block how much water they should be putting there, how much fertilizer they should be putting there, whether they need to apply herbicide, or whether there are pests appearing in those 10 square meter blocks, and they can do that in a very early stage so that they can do early intervention. So those are, as I say, technologies that people are already applying in their early stages and are starting to improve crop yields significantly or improve financial yields through the prediction. The other obvious thing you can do is track animals. Now, this is a silly example because it's my cat in Melbourne, but the reason I give you the example is this thing is a company in the States where they sell you a thing that plugs into your broadband modem and a little tag. That's the size of the tag. It's $150, And it's small enough and light enough to put on a cat. That is my cat. My wife thinks I was being cruel, but he actually didn't seem to care about it at all. But the amazing thing about it is they've got it so tuned that they can get a 40-day battery life out of this thing on the cat. One of the reasons, of course, is cats sleep 21 hours a day. And if they're sleeping, it doesn't trigger the battery. But as soon as the cat gets up, it starts telling me where it is. And you can geofence it. So I could get alerts when my cat went out of the house and went away. And of course, then I could find him. Now, the technology, you could probably, has about a half a square mile radius for one of those little $150 base stations. So to actually cover a rural area with this technology, it uses public spectrum, is relatively cheap and easy. So those types of technology will not only give you the tracking, but will also enable you to get the coverage you need for certain tasks, not all, at a relatively low cost. The other thing people are coming up with are ways of tracking your product. So this is a chip that comes out of MIT. It's a barcode. It's an RFID barcode, just like the ones we have in our phones to do the tap and go payments. But it's got a little resistor in it that's sensitive to certain chemicals. And if the food starts going off, those chemicals are released, and it changes the actual code in the chip, so that a customer in the supermarket can simply go, like we do with Tap and Go, can go up to the package and just tap on it and see whether the food is fresh or not. And of course, the purchasers of the distributors of the food can do exactly the same thing. But sometime in the future, you're going to be able to track, using genomics, an individual farm's production all the way to the customer. So someone told me that there's something like 20 times more bottles of grain floating around China than have ever been produced. So one would have to assume there's something wrong there. One day you will be able to take the actual genomics and tell where the grape came from and whether that bottle of grain is genuine or not. The reason for that is this is a curve showing the rate of progress. Now, this gray curve is the rate of progress of computers over the last 40 years, so-called Moore's Law, and that's driven our entire productivity economy and the internet and all those things. That's the rate of progress of genomics, of being able to do a gene sequence. Expect that within 10 years' time, we'll all have our genes fully sequenced. When you go into the doctor, the first thing they'll look up is whether you're prone to a particular type of disease or cancer, and someday they'll be able to fix that by 3D printing a pill for you on the spot. We're not quite there yet, but it's certainly feasible. These are some of the machines, by the way, that are making it so cheap. You can see this one, they actually attach to a mobile phone. It's a gene sequencer. In terms of measuring things in the actual field, this is an example of a device which will measure the ripeness of fruit. It does it non-invasively, so you don't actually have to destroy the fruit. And one day, again, this is a $200 device. It works by using ultraviolet light to stimulate the chlorophyll in the fruit to emit a spectrum of light, and then it's a spectrometer. It measures the light and can tell you whether the fruit's ripe or not. And we'll be able to place those in the vineyards, so they're all in the orchards, so that you can directly get online the state of readiness of your crop. Now, I mentioned some of those gains in terms of units of production and usage of water. A lot of this might come through indoor farming. So that strange-looking person over there is actually me in the world's biggest indoor farm, which is in a depressed part of Newark, New Jersey. It's enormous. You can see that these are the production lines of that farm. And what they're able to do is, it's a clean room environment, which is why we're all wearing masks and hats and things like that. But basically what happens is these are conveyor belts, and they put they're doing horticulture here. It's all green leaf vegetable. They put the seeds in at one end, they shine lights, feed water and fertilizer onto it, or nutrients onto it, and at the other end out comes a crop, goes straight into the punnet and straight onto the supermarket shelves. And in fact, some supermarkets are even building these sorts of production line directly in the supermarket, so it comes straight in. When you buy your vegetables, they come straight off the production line. They are able to optimize the system, and of course it's indoors, so there are no pests, there are no weeds, so they don't need any chemical spray on it at all, which makes it attractive from a marketing point of view. And it's completely optimized. They don't employ agronomists in there, they employ machine vision PhDs and things like that, because it's the technology that drives the productivity. I mentioned those quantum computers, and the reason I do it is because one of the things they will be able to do is redesign molecules. Now, that might sound pretty obscure, but it turns out that ammonia fertilizers consume 2% of the world's entire energy supply, which I find is an astonishing figure. But that's because they have to produce it at high pressure and high temperature, and of course it ends up as a high cost to you as an input. People will use quantum computers to change the way in which those fertilizers are created and to create catalysts that allow you to do it at a lower temperature or a lower pressure or both, and therefore reduce the cost of the fertilizer and make it more freely available at lower cost. Synthetic proteins, I mentioned, there are already people who are making artificial hamburger patties. The first one cost $380,000 to produce. They're down to a mere $5,000 now, but by the early 2020s, they're expected to be at the same price as a normal hamburger patty that comes out of a cow. They won't produce methane, and they will not require any animals. They do actually, they require a small amount of animal material to kick-start the process. Thereafter, it's all a factory process. Same thing for milk, etc. So my favorite one is, what's the world of the future going to look like from cars' perspective? Now, I don't think this is a major issue in Gunnedah, but that's what an intersection in a city would look like in the future. There are no traffic lights, no one's stopping. You'll notice that the cars are platooning, which means they're sort of going in a group through the thing, and that will completely change our transport system. It may require a certain amount of user education. Watch the guy at the end. Yes, I know for those of you who've been to Hanoi, it does look like Hanoi on a normal day, but no one's crashing in this particular environment. Watch that guy. I mean, would you do that? Someday you will, perhaps. The other thing we can start seeing is actually creating digital people. So the first thing that's happening are these exoskeletons, which of course enabled you to do things like lifting much more effectively without straining your back. And people are not, people are already starting to apply that for jobs that do require lifting, but ultimately we'll be able to create entire digital human beings. And there's already a group that's working on creating a robot soccer team, which they aim to beat the human World Cup champions by 2050. And once you can do that with a robot, you can pretty well do any human task that we can think of. The most difficult thing for a robot to do is grasping, by the way, but already people are starting to solve that problem. 3D printers, most of your supplies, your spares in the future will come from a 3D printer. You won't have it delivered. And with that, I'm going to end and open for questions, because you're welcome to ask me or challenge me on anything, including Telstra service. But I have questions for you as well, because really what I'm trying to understand is, what is the state of automation of your farms, and where do you see yourselves in this perspective of a future in automation? And Phil mentioned, what is the takeout message? My takeout message is, we're seeing a progressive increase in automation that's almost unstoppable and will continue for the next 30 years. So with that, as I say, happy to throw it open.